That's just going to be 0, so that's just going to be tan of x. And so there you go. Little bit of work there. Okay, so now let's solve these guys. So solve the following, giving specific solutions in the interval to 0 to 2 pi, non-inclusive. Okay, so one of the things we talk about is to not have these conflicting angles. So I'm going to change this to one of its identities, and since sine is here, I'm going to pick the one that's going to benefit me, and that's going to be 1 minus 2 sine squared of theta. So that's just a replacement from here to here. Plus sine of theta. I'm going to go ahead and move this over because it looks like a quadratic equals 0. So negative 2 sine squared of theta plus sine of theta plus 3 equals 0. Let's send a negative through. We've done a ton of these. Let's factor it. 3 and 1. Signs are different. I need this to be negative, so the negative on the heavier number here. And let's just use zero product property. Okay, add 3, divide by 2. This is going to be too big. No solution, okay? And then sine of theta plus 1 equals 0. Sine of theta equals negative 1. Theta equals inverse sine of negative 1, and that is going to happen at 3 pi over 2. Okay, the dreaded number 13 problem. Okay, so I solved this on a key a certain way, and then another student in another class solved it a different way, and if you look up this problem online, you know how you can do that. I guess you guys probably didn't know you could look up problems online, huh? I'm just kidding. It's solved both ways. So it's like, you know, you've got one posted it the way I've posted it on my key, and then another person is doing it like it was solved this morning in first period in another class. So I don't really know what to do about that, but I'm going to keep it simple. We won't put, you know, something like this around the test. I would accept both solution sets. And we'll speak to that in just a minute. So I'm just going to solve it with the school of thought that was taught to you in class, in that we don't want these conflicts of angles here, okay? And so we're going to replace this double angle then with its equivalency, so everything is in terms of the same angle. All right, so that double angle is 2 tan x over 1 minus tan squared of x minus, let's get everything in the same trig function. So we're going this route because in class we talked about getting at the same angle and getting at the same trig function. And so that is something we've talked extensively about. So that's why I'm going this route. And we'll talk about at the end the other solution. Okay, so next thing you should think is, hey, let's do the math. 2 tan squared, okay, minus this 1 minus tan squared of x. And that's just giving this LCD. So once you get the LCD, this needs a tan, this needs, you know, basically this needs this denominator and this needs this denominator. Okay, so if you have, you know, when is something going to equal 0? When is a fraction going to equal 0? I mean, and you can think of this two different ways. Basically, you just need the numerator to be 0. And then, you know, students are like, where did the denominator go? Okay, well, you can think of two things. It either cross-multiplied out, because it's going to get multiplied by 0, or you can think to yourself, you know, if I had a simple here, okay, I could just say, you know, cross-multiply x equals, you know, x over 1, or, sorry, x times 1, 0 over 1. X times 1 is just x, 5 times 0 is just 0. Or you can just think to yourself, well, for this to equal 0, this must be 0. I don't care what this is. Doesn't matter. It can be 5, it can be a million, it can be a smiley face. It's going to 0 out. So right here, we're just letting the numerator equal to 0 because that's got to happen for this whole fraction to equal 0. Okay? And so let's simplify it a little bit and see what we get. 2 tan square root of theta minus 1 plus tan square root of theta equals 0. So that is 3 tan square root of theta. I'm going to go ahead and set that to 1 tan square root of theta equals 1 over 3. A lot of you missed this on the quiz. When you square root both sides, plus or minus, okay? Plus or minus. That's hugely important. That's the square root theorem. So we're looking to see where the tan of x equals plus or minus root 1, which is 1 over root 3, and when rationalized, where is the tan of x equal to plus or minus root 3 over 3? So that's all quadrants. And use a trick. 3 plus 3 is 6. The trick with tangent. 3 plus 3 is 6. So these are all going to be over 6, all 4 quadrants. Okay, so we've got pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay, so the other method would be changing everything to sine and cosine. And when you do that, you get an additional solution of pi over 2 and 3 pi over 2. And if you put pi over 2 in here and 3 pi over 2, pi over 2 in here and pi over 2 in here, it certainly works. Pi over 2 would be tan of pi, which is 0. Cotan of pi over 2 is 0. 0 minus 0 is 0. If you put 3 pi over 2 in here, you get tan of 3 pi, which is 0. The cotangent of 3 pi over 2 is also 0. 0 minus 0 is 0. So there are these other two solutions. Okay? And so we have actually been talking about this as a math department. This process here does not reveal these two solutions. But there's no fault in this argument. So if something like this came out of the test, everybody would get credit if you gave these 4 or these 6. The way you get these other two is to use the strategy that we write everything in terms of sine and cosine. And that's legit. And so maybe we lose these solutions in this method because tangent has those asymptotes, as does cotangent. And so we kind of maybe lose solutions on the asymptotes. And we're trying to look in this interval, you know, and so if we change the sine and cosine, we don't have any asymptotes there. So I don't really know. I would have to research. Like I said, online you see about half the solutions have this and half the solutions have all of them. So I don't know. What do you guys care about? Your score, and if something like this were to come up, you'd all get full credit with either kind of school of thought there. Okay, so if cosine is 24 over 25 and we're in quad 4, answer the following questions, and we're going to do all double angles. So let's get into quad 4. Cosine 25, 24. Pythag here, you know, you're just going to do 25 squared minus 24 squared is going to be, what in the world? I did not do a minus sign. Oh, that was crazy. Crazy 49, so we're going to get 7 here. And you're probably used to that. It's coming up. I'll save ourselves some space here. All right, so here's our situation for theta. Okay? All right. So let's see what 2 theta is. And these identities use plain old theta. So 2 theta's here. We'll figure out where plain old theta is in just a minute. So this is 2 sine theta cosine theta. So 2 sine of theta here is negative 7 over 25 and 24 over 25. Okay? Sine is negative 7 over 25, 24. There you go. And we tried to give you nice ones to multiply on the test. But if you have to do a little bit of long multiplication, it won't kill you. 14 times 24 is not so bad. This is 3. It's negative 336 over 25. Okay? So cosine, you have 3 to choose from. Eeny, meeny, miny, mo. Let's just use the lower number, which will be sine. Let's use 1 minus 2 sine square root of theta. There are 3 to choose from, okay? What did I do on the key that's posted? I think I used cosine squared minus sine squared. You could have used 2 cosine squared minus 1, your choice. Okay, I'm just picking kind of the easiest ratio over here of 7 over 25, negative 7 over 25 squared. So this will be 1 minus 2 times 49 over 625. 1 minus 98 over 625. 625 over 625 minus 98 over 625. Okay, 527 over 625. There goes the 7th period bell. Okay, so there are those two. Okay, and then for tangent, you can for sure do sine over cosine. Why not? And those denominators would cancel, and you just get negative 336 over 527. All right. Based on the initial information in the problem and your answer to part A, which quadrant does angle 2 theta terminate in? So we're using this information to decide that. And we've got that sine of this angle is negative. Cosine of this angle is positive. And tangent, did I miss? No, yeah, that's the cosine. And tangent of this angle is negative. So therefore, this is quadrant 4. All right, and then it says to calculate the degrees and verify. So you're not going to have a calculator, so you're not going to have to do this on the test. But just for grins, let's just look at what we would do here. We would take cosine here. It's 24 over 25. So theta itself is inverse cosine of 24 over 25. I'll go in degrees, yeah, just to make us, so we can make sense. So that's about a 16.26 degree angle. And cosine thinks we want to be in quad 1. But it told us in the initial that we were in quad 4. Okay, in the initial problem, we're in quad 4. So I got to put a 16 degree angle in quad 4. All right, so a 16 degree angle in quad 4 is just going to be 16.26. That's the reference. So we're just going to circle around and subtract from 2 pi. So 360 minus 16.26 is going to be a 340. 360 minus 16.26 is going to be, okay, sorry, I took a pause because my key says something weird. It doesn't say 343.74, but it's 343.74 when you calculate. So double that would be times 2, 687.48. Okay, and that's pretty darn close to 720, and let's just see, 720 minus 687.48 is certainly 32 degrees away from that 720, so that is certainly also a quad 4 angle. So 2 theta is a quad 4 angle as well. So we started with a quad 4 angle, and when it got doubled, it landed once again in quad 4. But again, no calculators on the test, and a few of you asked me that in class. So don't stress about this, just go to this part. This extension won't be on the desk because we don't know, we don't have calculators. Okay, so that went pretty fast. That was page 2. Take a little break and start on page 3. All right.